Hello, gorgeous. Let's come back to the reaction number 4, I guess. Is we have 4? I think so. Right now we have the oxymercuration-demercuration. Okay, this is another way to add water onto an alkene. They follow Markovnikov's rule. Okay, and also prevent rearrangement. All right. Now let's see how do we use it, like how to predict the product. Well, let's take a look at this guy first. Okay, so don't worry about the rearrangement in here. Okay, so go Markovnikov. So water is a reagent. So this carbon is a Markovnikov carbon. The more substitute carbon, the product is this two. Okay, adding water onto it. And remember, the alkene is flat, trigonal planar. Water can attack on the front, the top face, and the bottom face. Okay, so you get this two. Yeah, that's the chiral center. If the Markovnikov carbon is not chiral, it's not a chiral center, attack on wedge and dash, same compound. You get only one. Okay. Oxymercuration-Demercuration can be used with other types of nucleophile. It doesn't have to be water. Alcohol look just like water, just replace hydrogen with an alkyl group. Okay, same thing. You can get alkyl group right here, just right here. Markovnikov carbon, wedge and dash. Okay, we call this reaction alkoxy-mercuration-demercuration. Okay, what alkoxy come from like this group right here. So water OH group we call hydroxyl group, OR oxygen, and alkyl group we call alkoxyl group. Okay, like sodium methoxide and sodium ethoxide. This is the alkoxy group and alkoxy group. Okay, work for many nucleophiles, even amines. Look at that. You can go right there too. Okay, let's practice this together. You can pause the video and just predict the product first, and then when you're ready, start the video and check with me. I'll just keep going. Okay, let's see. So we do oxymercuration-demercuration. So water gets on the more substitute carbon, the Markovnikov carbon. This carbon is flat. Okay, OH can attack on wedge and dash, so you get this two, wedge and enantiomer, the dash one. B, same reaction, but we replace water with an ethanol. So ethanol ethoxy group right there will attack that carbon. You get the same thing, just replace hydrogen with a ethyl group. Okay. All right, part C, the first one, be careful. This one we do acid catalyzed hydration. Okay, go through a carbocation. Rearrangement could happen. Let's do the non-rearranged one first, unrearranged one. So let's say this is the Markovnikov carbon. Always go there on wedge, on dash. Okay, so you get this. Okay, rearrangement could happen. So if the carbocation is right there, you have to draw the reaction mechanism. Okay, so the carbocation will be right there, and you can do a methyl shift, changing the reaction center to this carbon, and water can attack right there. So there's a possibility that you get this one too. This is the reason why we don't do acid catalyzed hydration in synthesis, because you can get multiple products. You know. Let's say, all right, next one, we do what? Oxymercuration-demercuration, no rearranged product, just this guy, there we go. Okay, so we go through the mercurinium, not rhenium, Ri, mercurinium ion intermediate, and then water attack on the more substitute carbon, the Markovnikov carbon, and then you get this. All right, one more time. Let's see what we got. The first one, again, so this is acid catalyzed hydration. Don't want to do this reaction. I mean, they're going to rearrange. Possibly could rearrange. All right. All right, I'm going to predict all the products. Okay. The step one is going to be, so let's say, protonation. Okay. So the proton transfer, the carbocation right there. Water will attack on that carbon. So carbocation is flat. You get wedge and dash. Okay. This is wedge. This is dash. There's a rearrangement could happen. Okay, so a methyl could shift. Probably not going to do ring expansion because 6-membered ring is already stable. Okay, 7-membered ring is less stable. We're not going to do that. All right, so we take methyl and shift. You can do that too. You get a more stable carbocation, and then water can attack on that carbon. This is not the chiral center. You get only one. Wedge and dash are the same one. Okay, this one is oxymercuration-demercuration, so water attack on that carbon on wedge and dash, just these two, no rearranged product. Look like this. Okay, all right, reaction number 5. Okay, last one, y'all.